In this lesson, we're going to prove the power rule for when n is a rational number. Now, if you recall, we first proved the power rule was true only for n being 0 or a positive integer. Then, after we studied the quotient rule, we were able to prove that it was also true for negative integers. So then we had it being true for all integers. Well, now, having studied implicit differentiation, we can now prove that it holds for all rational numbers as well. Now let's first of all recall what a rational number is. A number r is said to be a rational number if it can be written as the quotient of two integers, like a divided by b, where a and b are integers, like 15 over 32. That would be a rational number. Now equivalently, r is rational if its decimal expansion either terminates, like in 1/4, that's 0.25 and then it stops, or it repeats, like in 1/3 would be 0.3333, and it just keeps going like that. That's an equivalent representation for a rational number. It is possible to show that if you have a decimal expansion that repeats, that you can write that number as the quotient of two integers. We're not going to do that now, but that is a fact. Now let's prove the power rule for a rational number when n is a rational number like a divided by b. So we'll start out with assuming we have a function like this, where a and b are integers, and then what this is equivalent to stating that see, all we did is we took both sides and we raised both sides to the b power. So we get y to the b equals x to the a power, where a and b are both integers now. Now we're going to assume that y is a function of x, of course. It is. So y is a function of x. Y to the b, function of x, equals x to the a. And now what we're going to do is differentiate both sides with respect to x. Now this side, a is an integer, and we already proved the power rule for an integer, so we know that this side is going to be a times x to the a minus 1, so we'll write that out. Now this side right here, we need to use the chain rule on this side. So we're going to write this side as follows. So you see, here we have the chain rule being applied to this side. We want to differentiate y to the b power with respect to x. So we write it as d dy of y to the b times dy dx. Notice how the dy is here. We can think of them as canceling, and you recover your d dx. So that tells you we're doing things correctly with the chain rule. And the right-hand side over here, we just differentiated this. So we dropped the a down, subtracted 1. Now we already proved that we can do this because a is an integer. So now we have to evaluate the left-hand side, and that is going to become now, we know that we can differentiate this because b is an integer, and we already proved that we can use the power rule when b is an integer. Now, we're going to take this, the b, y to the b minus 1, and just divide it to the other side to isolate the dy dx, because that's what we want to obtain. So we're going to get then now, the y we know is equal to x to the a over b power. So we're going to put that in place of the y, and what we get then is the following. Now, by properties of exponents, we're going to have to multiply a over b times the b minus 1 in the denominator here. And we're going to get and then just subtracting this exponent from this exponent, we end up with alright, so notice I distributed the a between the b and the 1 here, so we have ab minus a minus this whole fraction. Now what we have to do is, let's just simplify this exponent right here, and we'll see that what we end up with is a divided by b minus 1, and that will prove the power rule for a rational number. So let's just take that now, and let's note that a minus 1 minus ab minus a over b. Now what we're going to do is we're going to cross multiply. So we think of this as being over 1, and so we're going to go b times a minus 1 minus 1 times ab minus a, all of that over b, and let's see what we end up with. So we will get here alright, so we took b times a minus 1, right there it is, minus ab minus a. Notice that we wrote the minus a as plus a here. And now this simplifies as and these cancel, and then we end up with a over b minus b divided by b. So we have then when we split this fraction apart, we have a over b minus b over b, which is 1. And so coming back up here then, what's circled in red is equal to this. We've just shown it's equal to this right here. And so what we have here then is equal to, all of this, will just erase this part right here, since we've done that work already. And so we've now argued that this is equal to a over b x to the a over b minus 1. That's what all of this is right here. So the two terms circled in red we've now shown are the same. And so what we have now is dy dx equals a over b x to the a over b minus 1. And since y is equal to x to the a over b power, we have and so this concludes the proof of the power rule for n being a rational number. Notice we've shown that the derivative of x to the a divided by b power is a over b. You drop the a over b down in front of the x, copy it down, and then subtract 1 from the exponent. And that's exactly the power rule. And so that concludes this lesson.